much, and yeah, I can try to entertain you. And from the second point, this talk is about fear and no fear. So, as software people, sometimes you may be really scared by building your own devices that may help you to test software, but in this talk I will try to remove this fear and maybe inject some enthusiasm into your typical tool set you use in your automated tests or even in the manual tests. So, short introduction, who am I and why I'm here. So I'm for quite a long time in an industry. So being a developer, software tester, testing manager, test architect. So I started to talk about different aspects of quality again, probably 10 years ago, more than 10 years ago. I've been main branch of this conference, chair of the program committee several times. And around 4 years ago, I started to get a bit bored by simple talks about just software quality. So I started to find something new and something in between of testing and something else. So my primary interest in life is about engineering actually, and it can be software engineering and it can be electronics engineering, it can be car engineering. So engineering activities actually started at the age of 5. And for this talk, I need to warn you that I'll have lots of QR codes on the slides. So some topics are maybe too long to cover in this presentation, so don't hesitate to scan those QR codes and they will lead to some supplementary reading sites, so please do. That's the photo from Pope announcements actually, how it changed from time to time, so yeah, just don't hesitate to scan QR codes. So to start, actually, the idea of this talk was born maybe a year ago or a year and a half ago from a really strange and really simple case. So we had a test bench. It was a dedicated laptop running automated tests, and it also was used by our outsourcers for remote access. This laptop was in Windows domain, and control of screensaver was enforced by domain policies. So this laptop slept over time, and due to specifics of the software, we cannot change the sleep time of this laptop. And from the other point, it was total nightmare for software under test. So this laptop shouldn't sleep at all. Otherwise, the connections was lost, and so don't ask me why. But so first of all, we asked someone close to this laptop to move the mouse each 15 minutes. So not a really engineering solution, right? So maybe manual support of your test environment. So we started to think how to maybe automate this process, and we started with pure software solutions. Which were actually unreliable because software hangs, software cannot restart after laptop restart after software updates. So again, we are in corporate environment, and updates are coming when we are not waiting for them, and those updates can shut off the software. So naturally, we came into a hardware solution. So the idea was really simple. We need some piece of hardware which will move the mouse and prevent our test laptop from sleeping. So first solution. Really stupid one. So how it works? We reprogrammed our office phone station and made redials each 10 minutes. So then this phone made a buzz and mouse moved a bit, and that prevented the laptop from sleeping. So lots of complaints came because unpredicted buzzes each 10 minutes in the office, so not really convenient thing. So this solution survived, I don't know, maybe 1 day or 2 days. Next iteration. A bit less stupid, do-it-yourself hardware. So yeah, so if we cannot move the mouse, let's move the table. So, or in this case, let's move the fan. Actually, if you use color fans or light-emitting diodes, so that setup is really, really cool in the night. So it was something which eliminated night shifts and late workers. So again, a really, really stupid solution, but it works and it's do-it-yourself hardware, right? Before preparing this talk, I tried to Google a bit, so just to do some, I don't know, medical check. Am I totally crazy or not? But actually, I'm not alone. So that's the screenshot from one Reddit post, and the guy here made literally the same, but with the hands of his watch. I don't know if it's Rolex or if it's something less expensive, but yeah, doing the same trick. So that solution with the fan, so it's okay, but it's not scalable at all, and it may be, again, a bit noisy over time. And as an engineer, I try to come to a more elegant solution. So one of the elegant solutions that could be, so probably you already heard that buzzword, Arduino. So actually that's a project that was born around 10 years ago, and primary idea of this project was to teach school children to make hardware and to program hardware. So I think if it's good for school children, so it can be also good for software testers. So that's one of the ideas of this talk. So you can use it, and you can use it pretty simple way. So the idea was to build mouse simulator with these small microcontroller boards to plug it into a laptop and to make the laptop feel like it's a mouse, right? So the whole setup actually took literally 3 lines of code. So mouse begin, mouse move, and some delay. So that's all. That's all we need to make your own do-it-yourself device for a really, really simple test environment setup, and that's something that you can get in 10 minutes, and it will run. So I'm pretty sure that it runs now in this testing laptop. So it's in Moscow, but yeah, it works for more than 1 year already. So pretty rock solid setup, and it survived all the corporate software updates. This setup can be used not only to simulate mouse, but it can be used for fuzzy testing. So erratic mouse movements can be simulated with this setup, or even erratic keystrokes and usage of the keyboard can be simulated with that device. But also some scenario testing can also be used. Actually, why we even can start to think about using hardware in our software testing setups. That may be fun, but sometimes it's easier to build hardware than software. So just imagine, so if we try to make that mouse simulator in software, so probably it will be a bit longer than 3 lines of code, right? And here we made it in 10 minutes. Hardware and even self-built hardware can be used to do some really, really bad to our software that we just cannot do with the software. So we can do much more with hardware, right? So we can do something really stupid, like with the phone and the mouse, just to entertain us, or just to make, again, something bad to our software that developers cannot invent or cannot predict. We can simulate real-life conditions. So after all, our software runs on some real servers, on some real laptops, and we may simulate real life to affect our software, and we need to build some pieces of hardware ourselves. Or we can do it just for fun. So just remember that QA engineer is also an engineer, and you may have some fun from pure engineering tasks. Yeah, so we can give effect with hardware to other hardware, so we can replace some parts of our systems with our own hardware. So that's like with the keyboard and with the mouse. So we replaced normal real mouse with our own self-built hardware. We can give an effect on other pieces of hardware with our own hardware. So a bit later in this talk, we'll talk about radios. So we can give an effect on mobile phones with our own self-built devices. Or we can give all kinds of effect on test environment. So again, for different reasons, but we may want to make it unstable or rock solid stable. And actually how we can do it. When we are talking about automation, so that's all understandable. We have some frameworks, we have some libraries, we have some typical existing projects that we can reuse. That's a surprise, but we have exactly the same in the hardware world. So 10 years ago, when I wanted to build really simple hardware devices, I literally couldn't do it because all the components weren't available at all. So now we can order for, I don't know, 10 bucks, 5 bucks on different sites, some pieces of the hardware, and they are so well documented, and they are good to be used by school children and virtually by anyone. And we can easily build anything like we build software. So just we take some pre-built modules, we connect them with the wires. Sometimes we may want to solder them, but not in all the cases. And we are getting hardware devices as their results. Maybe let me continue that example with the mouse, and actually we can do the same with the keyboard. So no one prevent us from making our own keyboard to simulate user sitting and typing something. And the good thing is that we actually can do Bluetooth keyboards ourselves. So that's the sample of a pre-built model. So it costs about $3 or $4 on one of the sites. And it can simulate almost all types of Bluetooth protocols. So, and good idea about this model is that it has only 4 wires here. So 2 of them are actually power, so plus and minus, and 2 of them are data transmit and data receive. So the concept is really simple. So like for software code functions, you have some parameters that you are transmitting to your function, and there are some results that you are getting from the function. So the same applies to hardware models. And in order to control this model, we should add another piece of hardware, which is called serial port adapter. So that's the thing that actually converts symbols we send into our USB to some raw serial symbols that are really sent to Bluetooth model. So combining them, we are getting keyboard simulator. So, and if we connect that keyboard simulator to our PC or to our mobile phone, we can use some test driver, and without any changes to software under test, without any code injections, without any testing frameworks, we are getting really simple solution to drive our tests, and we can execute our tests not on the software emulators, but on the real hardware. And this setup is as simple as connect 1, 2, 3, 4, 5, 6 wires. And yeah, the price of the total setup is less than 10 bucks. There is one caveat in this setup. Actually, not every Bluetooth model is good enough. So there is the name, it's RN42. I don't know if 42 is connected to Douglas Adams or not, but maybe yes, I don't know. But the problem is that it's a closed source proprietary Bluetooth model which can simulate mouse or keyboard. So cheap clones cannot simulate mouse, but there is the project how to modify cheap Bluetooth adapters and make them capable of simulating mouse and keyboard. So again, you can use your Googling skills and your creativity to do something even with the hardware that you're getting. There are some alternatives. So this stuff is Logitech mouse actually, wireless one, and you may want to simulate Logitech wireless protocol as well. So there are special devices which are already built, and you can build them yourselves, or you can buy some pre-built models and program them. So again, that's the simple way of setting up your automated test environment without any changes to the software under tests. You are not changing anything, but you are just injecting the keystrokes and you are executing your tests. Yeah, web USB. So that's purely ingenious invention. So two Google engineers, probably 3 years ago, started to think we can connect our hardware to our PC, and probably we want to control our hardware from browser. So they created a standard, which is currently W3C drafts, but yeah, I hope it will be accepted someday. And the idea is that you can actually connect your small board, your small microcontroller to the big brother, to the computer, and you can control this stuff from your browser. So just imagine, just simple internet sites like settings of your test environments, like the script of your tests. It can be transferred to your own built hardware with a single mouse click from the browser. So again, that's really flexible, and you can use it, and it's really simple to use because there are lots of examples how to use this standard in practice in real life. So if we are talking about mobile devices and we don't want to solder, we don't want to buy any components, we don't want to connect them, so you may use this kind of automation. So just take rotating motor, and you can rotate this sausage with the speed you need and make as many dislikes or as many scrolls you want. So another kind of stupid automation, but still it's do-it-yourself hardware. So feel free to use this trick. Second big part of this presentation, radios. So you may want to listen to something, maybe something extra than just cool music on your radio station, or you may want to transmit some radio signals to control something. So here I need to warn you that radio transmission may be completely illegal in your country, or it may be illegal just on some frequencies or power. So please don't, without preliminary exploration of your laws and the regulations in this area. So transmission may be dangerous to do. I think no one wants police squad to come into your house suddenly, so be careful. There is one cool thing, so it's not USB flash drive. That's the thing which is called software-defined radio. So that's the thing that maybe first software-defined radio appeared 20 years ago, but they've been as big as a big house, and now they are small like a flash drive. And this device can listen virtually to any frequency, from musical radio stations to the cell phones. And the cool idea about that you can write software, or other people already written lots of software to listen to radio signals. And by listening to radio signals, you can control your test environment, or you can control your software under test. So with a simple USB flash drive sized device. So there is one magical frequency, it's 433. So that's the frequency of home automation or office automation devices, so like 4 times bigger than radio stations, FM radio stations. And another idea that we tried in the office is to start some tests after everyone leaves the office. So just because we don't want our environment to be interrupted by anyone, by the cleaning lady, by any kind of person who may stay in the office late. And here there is the lock of listening to radio frequency of our smart lock smart office lock, which actually transmits the state of the door locks and the doors in the office building. So when all the doors are closed, so it's a good time to start testing. There is one small cool project, it's called RTL 433. And it can decode lots of messages from different types of devices for home and office automation and for that smart lock. So it can decode fire alarms, weather stations, virtually anything that you may want to listen to. If we would like to give this stuff a bit of autonomy, we can connect it not to Arduino this time, but to a Raspberry Pi, so another buzzword that you may be aware of, but that's like a de facto standard for small one-board computers. So that little thing runs Linux inside, so if Arduino starts working in milliseconds after you power it up, so this thing should boot Linux, but you can put any kind of normal Linux code inside. And the coolest thing about that, those contacts on the right. Let me try. No. These contacts on the right. So you can connect your own devices and you can control your own devices with the simple on-off switches of Arduino. And there is one cool project, it's called RPI-TX, Raspberry Pi Transmit. You can connect just one wire to your Raspberry and you can transmit virtually on any frequency, any message you may need. So again, it may be illegal, so please do preliminary research, but let's imagine the situation. Your test environment just hanged up, and it's middle of the night and the test is really important to be completed today. So this stuff can transmit a voice message to your night guard walkie-talkie. Please come and reboot our test environment, please, please, please. And actually this idea is not as mad as it could be from the first sight, because one of my friends, 15 maybe years ago, so during his vacations, he connected doorbell button to the reset switch of his home server, and he asked his friends to come and ring the bell to reboot his home server when it hangs. So literally the same idea here, but at the maybe higher level. There is one interesting project which also can be used to make radio transmissions, but on AM frequency, so maybe not as widely used as FM radio stations now, but if your night guard is 80 years old and he still have some tube radio, so you can even transmit with slightly different microcontroller some voice messages and someone can listen to it and it can be used like indicator of the status of your test environment, for example. Another cool thing, which is again about receiving something from the sky, that's GPS receivers. So I think everyone have GPS or GLONASS receivers in the mobile phones, and for most of the people it's just pure magic, something in the sky which is transmitting the coordinates, and then we start Google Maps and we know where we are. So technically this stuff is actually transmitting our coordinates in some form of the messages, and more important, this stuff is transmitting time, really precise time, like atomic clock. And if our test environment is not connected to internet, but for our own tests, it's really important to have precise timing. For example, if you are testing video processing software or like any kind of software you can imagine, you can get precise time not from the internet, not from NTP server, but directly from the sky. So with a simple GPS receiver, so there is the standard which is called NMEA, just text messages, and one of the messages is containing time decoded from satellites. Again, it's really cheap to get, and it's really easy to set up and to inject into your test environment, so that's not rocket science. You can do it really easily. Yeah, that thing I especially like. So some crazy German guy a year and a half ago discovered that if you purchase really cheap USB to VGA adapter, so that black thing in the top left corner, that's the external video card that you can connect to your laptop and get VGA port, can be reprogrammed, and you can simulate GPS and GSM signals with that. So you can affect your mobile phones, and you can create some specific conditions when you are testing your mobile applications. So you cannot do it with software, but you can do it with small piece of software and small piece of hardware, which can be easily done. Yeah, so we started to talk about mobile applications. So another interesting thing is to do radio jamming. So have you ever tried to think if your application will survive with no radio situation? So when the GSM stations are not available, no 3G, no Bluetooth, no Wi-Fi, no nothing. So some applications do not survive that radio silence situation, and if you want to test it, you can just make passive radio jamming. So you can put your mobile phone for several hours to Faraday cage, so the device that prevents radio waves to come in. And yes, sometimes that's really surprising results. So I've seen several applications that just haven't survived that mode. So that's not airplane mode, but just radio silence. And you can do active radio jamming, but again, let me warn you that it can be illegal. So explore your local laws. And there are some devices that jam and prevent some kind of radio waves from propagation. So like to jam Bluetooth stations or GSM stations, which may be also useful for some kind of testing. So at the beginning of the talk, I told that we may also influence test environments, and it may give interesting conditions and interesting results. So one of the effects of the test environment, that's overheat and freeze. So you will be really surprised how many strange effects you may get on your software if you start to overheat your laptop or your PC or your server. So hardware faults are generating software faults, and by the way, you can trigger your hair dryer with Arduino. So you can combine the models. Yeah, and you can use relay model for that, so you can control with low power signal. You can control 220 volts in your mains to turn on your hairdryer. Or you can do that thing. So probably someone heard about people called overclockers. So they are putting liquid nitrogen and they are speeding up computers, but also putting computer in extremely low temperature can give unpredicted effect on the software. So if your software should run together with Eskimo and Huskies, so try to put your laptop in the fridge first. It may be useful. Yeah, so that's the sample at my previous employer. We stole those IKEA ice cube makers from our office fridge, and we use it to put our mobile phones on our test bench for mobile software. So a bit of creativity, so just a small hint. So we had like 7 stands holding 35 mobile phones running automated tests. So just, again, self-made hardware at some point. Yeah, so just to reiterate, so this is the list of the models that you can get, and you can just use it as the reference or starting points. And the good point about that starting point and those models is that they all talk standardized interfaces. So I told you that it's really simple to writing code, and if we are transferring data from one model to another, so it's relatively easy to understand how to transfer this data. And again, that's the list of useful keywords to start with, and the link leads to some explanation article what these interfaces are about. And yeah, again, if you understand the concept of transferring variables to functions and getting the results, you can easily grasp the concept of transferring signals over wires. It's quite the same. Yeah, so those are actually cool sites that can be source of hardware models that you can build and inject into your test environment. So that's AliExpress. So I think that I shouldn't introduce these hypermarkets in China, and surprisingly they are selling do-it-yourself do-it-yourself hardware models that you can use. There is one American site that's SparkFun company, and their primary customers are again school children and some hardware enthusiasts who want to build their own hardware, and you can buy some components from them. And there are two really cool sites, Tindy and CrowdSupply. So they are like startup aggregators, and their creators or makers can sell their hardware, and you can buy it and you can use this hardware in your own devices and your own ideas. So how to start? That may be a surprise, but there are lots of different communities in different countries about building your own hardware, and there are people exchanging ideas. And I can recommend sqadays.eu community. So that's the internet site which have the list of some crazy projects. There is the messaging board. They have regular events describing different kinds of technologies. They have local live events when people can meet in different countries. There is one community, so it may be especially interesting for Russian-speaking people. It's DIY or die, do it yourself or die. Yeah, there is the link to Telegram channel of that community. So there people are making regular meetups and events where they are sharing the crazy ideas. And there are sites, Instructables and Cool Tools. There you can find step-by-step instructions on how to build your own devices, how to build your own radio jammer, how to build your own Bluetooth keyboards, how to build virtually everything, and it's really simple and step-by-step, so that's a good place to start. Yeah, so let me probably reiterate. I promised you that this talk will be entertaining, but at the same time I tried at least to make it inspirational one. So please don't be scared by hardware. That's pretty easy thing. So the entry level to hardware building is much lower nowadays than 20 years ago. So virtually any person can start building the hardware. And don't be scared, build your own secret lab and use the force, but not too much. Thank you.
Any question?
Hi Nikita, thanks for the talk. My name is Ilya. Question about emulating mouse and keyboard. Let's say I use Arduino and those Bluetooth thingies to emulate it. How do I, what would you recommend for me to put that into my test harness, test framework? So is there integration with like unit tests or JUnit that I can use to actually trigger those mouse and keyboard events as part of my test suite?
So my recommendation would be to use that web USB protocol. So before execution of each test, you can directly guide your Arduino which keystrokes you need to execute, right? So and then Arduino will act instead of code injection. So there is the complex thing that's how to maybe analyze test results with hardware. So there is no easy answer. Maybe use camera and pattern recognition software, but yeah, it's easier to give effect than analyze an effect.
Hi, thank you so much for the talk. I wanted to ask, how do you usually prepare developers for this thing? I mean, you, as a tester, you need to give the steps for reproducing the bugs to the developers. So if you say log in and then put your laptop to the fridge, for example, so this there needs to be like an agreement for this in the whole team? Or?
Yeah, for sure. Yeah. So actually that's example with the fridge. So I haven't been able to find old photos from my previous employer. So we had the project Russia-wide, and some computers, so they literally worked in the ice in really distant areas of Russia. So we simulated those hard conditions with our own home fridges and with some industrial fridges. So it was an agreement between testing team and developer team that we would like to test such hard conditions.
Thanks.
Hello. I have a question about SDR.
Yeah, SDR. SDR, that's an acronym for Software Defined Radio.
Yes. Can we simulate GSM signal or GPS signals to affect our mobile phones or something like this?
Yeah, let me maybe return to one slide. Yeah, so you can transmit GSM or GPS signals maybe to 10 centimeters length, so it's not illegal because it's not really powerful, and you can use this project. It's called Osmocom FL2K, and it's not actually SDR device, but some other device used as SDR. Or there are some projects on crowd supply side. Here, yeah, here it is, crowd supply. They have more complex software-defined radio models that can be used to transmit GSM signals or GPS signals. So the problem with GPS that you usually cannot transmit it in real time because you need to calculate lots of space mechanics stuff to transmit correct GPS signal. But with GSM on lower frequencies, usually it's easier.
Thanks.
Next questions.
No questions. That guy really wants to get a t-shirt.
How many laptops did you kill?
That's a complex question. In which period? You mean per second? In my lifetime, I don't know, maybe 10. I restored maybe 20 of them. So they've been killed not only by me, but I don't know, maybe 10, maybe slightly more. More interesting question is about other types of devices that have been burned. Not laptops, but yeah.
Skynet is not going to have
Yeah, so that's another point. So don't be scared to burn something. You can easily replace one piece of hardware with another piece of hardware. So it's not like killing people, it's just burning out the devices. So don't be scared by that aspect as well. Okay, so yeah, I would like to give this voucher to this guy asking about software-defined radios.
Thank you.
Thank you for the question. And thank you for you all to coming here and listening to this crazy topic. Thanks.